Okay, these are the free response solutions from that packet that I gave you that I graded your solutions. So for question number 1, it's all about the temperature of the water in a tub, and we're told that when T equals 0, the temperature is 55 degrees. Okay, so part A is asking you to find W prime of 12, and you're using to estimate it. And there is no 12 on the chart, so we're going to use the points on either side of 12, which will be 9 and 15. And then we'll just do y2 minus y1 over x2 minus x1, and you get 1.017. Okay, so the question says estimate W prime of 12 and show the computations that lead to your answer. We did that. And then use the correct units. So the units are going to be degrees Fahrenheit. And then interpret the meaning of your answer in the context of this problem. So you would say at T equals 12 minutes, because it's set in the context of this problem. At T equals 12 minutes, the temperature of the water is changing. You can say changing or increasing, whichever one you want, at a rate of 1.017 degrees Fahrenheit per minute. Okay, and that is the answer for A. Okay, let's go to B. So B is saying to use the data to figure out what the integral from 0 to 20 of W prime of T dt is. So if you take the antiderivative, you're just going to get W of T as it goes from 0 to 20. So first you put in 20, and then you're going to put in 0. So now if you look at the chart, W of 20 is 71, and W of 0 is 55. So if you subtract that, you get 16 degrees Fahrenheit. So the question says use the data to evaluate this integral, so that's the answer for that. And then using correct units, interpret the meaning of this. So you would say the integral from 0 to 20 of W prime dt is the temperature of the water in degrees Fahrenheit in the first 20 minutes. Okay, you have to make sure you say in the first 20 minutes, otherwise maybe this is the temperature of the water, like after 30 minutes. So you have to make sure you specify that. Okay, and then for part C, which they're talking about from 0 to 20. This would represent the average temperature, which you already know that this is the formula. Okay, so use a left Riemann sum with 4 subintervals. So that means I'm going to have 4 rectangles, and I'm working from the left to approximate this integral. Okay, so I'm going to go back and look at the table, and so my first interval will be from 0 to 4, so that means the length is 4. The next one goes from 4 to 9, so the length is 5. The next one goes from 9 to 15, so the length is 6. And the next one goes from 15 to 20, so the length is 5. So now you just have to take the y value that goes with these from the left side. So from 0 to 4, you're going to choose 0, and that gets 55. And then from 4 to 9, you're going to use the one that goes with 4, which is 57.1. From 9 to 15, you're going to use the y that goes with 9, that's 61.8. And then from 15 to 20, you're going to use the one that goes with 15, which is 67.9. Okay, so if you multiply these, you should get these values. And when you add them, you get this. Okay, so let's go back to the question and see what they're actually asking. So they're saying use a left Riemann sum to approximate this piece up here. Okay, so this 1215.8 is the integral approximation. That's the area under the curve. So you're going to have 1 over 20 times 1215.8. And when you do that, you're going to get 60.79. So for this problem, you actually got points for doing the Riemann sum, and then you got points for doing the answer. And the next question is, will this approximation overestimate or underestimate the average temperature, and explain your reasoning? Okay, well, if you look at the chart, you can see the temperature is always going up. So that means the function is always increasing. So if the function is always increasing, and you're doing a left Riemann sum, so let me go to the next page. So if your function is always increasing, let's say this is my graph, and I cut it off here. When I take a left Riemann sum, it's always going to be lower. It's an underestimate. So you're going to write, since the function is increasing, that's what the magic word they're looking for, increasing. A left Riemann sum will be an underestimate. Okay, and that completes part C. And finally, let's go to part D. Okay, so for part D, this is going just from 20 to 25. They're talking about the first derivative is this. And they're asking to find the temperature at T equals 25. We just were talking about this yesterday. So if you want to know what the temperature is from 20 to 25, you're going to do an integral. But you have to know where were you when you started at 20. So at T equals 20, if you look at the chart, the answer was 71. So it's going to be whatever the temperature is from 20 to 25 plus another 71 degrees, right? Because at 20 degrees it was 71, and then it continues to increase. So this would definitely use a calculator. And so for this part, you should have gotten this. And then you're going to add the 71. And you should get 73.043 degrees Fahrenheit, which makes sense. Think about that. If it started at 55 and after 20 minutes it was at 71 degrees, after another 5 minutes it went up 2 more degrees. And so that completes that. Okay, so that's it for question number 1.